Okay students, now let's do the next question. Find the voltage across the 5 ohm resistor. So here is the 5 ohm resistor. So the question is find the voltage across the 5 ohm resistor. So how do you find the voltage across the 5 ohm resistor? First you multiply first you find the current across the 5 ohm resistor and then multiply that current with the 5 ohm. You'll get the voltage across the 5 ohm resistor, right? So which means here how I'm going to do this problem is I'm going to mark the first mesh as this one. This is I1, okay, and this is I2, and this is I3, okay, I1, I2 and I3. And then so which means the current through this 5 ohm resistor is I2. So multiply that I2 with the 5 ohm resistor. So you will get the voltage across the 5 ohm resistor. So let's do this question. First I'll write equation for mesh 1, right? Equation for mesh 1. So we have I1 touches 1 ohm plus 3 ohm plus 6 ohm. So here 1 plus 3, 4, 4 plus 6, 10. So we have 10 I1, right? Minus, and I2 touches only this resistor, so which is minus 3I2, and we have minus 6I3 is equal to, and if you look over here, this I1 is flowing from the positive terminal, right? So this positive terminal is generating I1, therefore it is plus 10. So 10I1 minus 3I2 minus 6I3 is equal to 10. This is the equation for mesh 1. Now equation for mesh 2. Equation for mesh 2, and that is in this mesh 2 only I2 is positive and I1 and I3 is considered as negative, and I1 touches only this resistor over here, so we have minus 3I1, and then for I2 it is 3, 2 and 5, 3 plus 2, 5, 5 plus 5, 10, so we have 10I2, and then there is no resistor that touches I3 in mesh 2, right? So the coefficient of I3 is 0, so this is equal to, that's it, right? There's no value of I3 over here. So now as for the voltage source, this I2 is flowing into the positive terminal, right? This positive terminal is supposed to be generating current, right? It's supposed to generate energy. So this usually the battery supplies the current, right? The battery supplies the current, but here the battery is not supplying the current, the battery is opposing the current. That's why. So therefore it is minus 5, right? In this mesh, the voltage source is negative, minus 5. Okay. Now, next is equation for mesh 3. Equation for mesh 3. So here, I3 is positive, I1 and I2 are negative. So I1 is minus 6, I1 over here. And then for I2, there is no resistor that touches I2 in mesh 3, right? So therefore, the coefficient of I2 is 0. So we have only I3 left behind, and I3 touches this resistor and this resistor. 6 plus 4, 10. So we have plus 10 I3 is equal to, now what about the voltage sources? There are two voltage sources in mesh 3, right? This 5 volt over here and this 20 volt over here. And if you consider this 5 volt alone, this 5 volt, this current I3 is flowing out of the positive terminal. That means this positive terminal is creating I3. So therefore it is plus 5 volt, right? And what about over here? This I3 is flowing in the clockwise direction, right? So here it flows from left to right. So if it is flowing from left to right, then this 20 volt supply is also creating I3, right? Because the direction of I3 is like this, right? So therefore this positive terminal is also creating I3, which means both the voltage sources are creating I3. See, here I3, in this branch I3 flows like this, and here in this branch the I3 flows like this. So both the voltage sources are positive. So we have 5 plus 20, which is 25. Okay, so this is how we write the mesh equations. Now expressing that in matrix form, writing the above equations in matrix form. Okay, so we have the coefficient over here is 10 minus 3 minus 6, 10 minus 3 minus 6. As for the second row, it is minus 3, 10, and the coefficient of I3 is 0. So it's minus 3, 10, 0. Minus 3, 10, 0. And as for the third equation, minus 6, the coefficient of I2 is 0, and coefficient of I3 is 10. So we have minus 6, 0, 10. Okay. And the unknown variable is I1, I2, I3 is equal to, and the voltage source matrix is 10, minus 5 and 25. Okay, now I'll find the value of I1, I2 and I3, right? So to find the value of I1 is equal to, the determinant of the matrix should be, the first column must be replaced with the voltage source, 10 minus 5, 25. 10 minus 5, 25. And the second column is the same, minus 3, 10, 0. Minus 3, 10, 0. And the third column is minus 6, 0, 10. Minus 6, 0, 10. Divide by, the denominator is the coefficient matrix, 10 minus 3 minus 6. 10 minus 3 minus 6 minus 3, 10, 0 minus 6, 0, 10. Okay, is equal to, so now let's find the value. 10 into, and we have 10 to 10, we have 100, and this is, okay, minus of minus is plus, plus 3 into, and we have minus 50, and we have minus 6 into, this is 0, minus 250, minus 250 divided by, this is the numerator, and the denominator is 10 into 100. Okay, minus of minus is plus, 3 into minus 30, minus 6 into, let's see, minus 60 becomes 60. Right, so this is the numerator, denominator. Therefore, let's see. So I need to find the denominator so that I can use the same denominator in finding I2 and I3. Right. So the numerator, it is 1000 minus 150, and this is minus of minus is plus. So we have plus 6 into 250. Right, 1000, let me check, 1000 minus 150 plus 6 into 250, so we have 2350. So the numerator over here is 2350 divided by, and for the denominator we have 1000 minus 90 minus 360, 550. So the denominator is 550. The reason why I'm finding the denominator separately is because I can use the same denominator for finding I2 and I3, right? That's why. So we have 2350 divided by 550, which is 4.273 amperes. 4.273 amperes, right? 4.273 amperes. So this is the value of I1. Now the value of I2 is equal to, now here the second column is different, right? The remaining is the same. So you have 10 minus 3 minus 6. First column is same, second column is different, 10 minus 5, 25, and the third column is also same, minus 6, 0, 10. That's the numerator, and as for the denominator, it is 10 minus 3 minus 6 minus 3, 10, 0 minus 6, 10, no, 0, 10. All right, so in here we have 10 into, this is minus 50. Okay, minus 50 minus 10 into this is minus 30, minus 30, minus 0, and then we have minus 6 into, and this is minus 75, minus 75, minus 30. Minus 75 minus 30 is minus 105. Minus 105. Divide by, here of course the denominator is the same, 550. So it is 550, right? So now I can find the answer directly. So we have over here as, let's see, we have over here as, the numerator is, this is minus 500, minus 500, minus 300. No, this is plus 300. Sorry, it's plus 300, right? Plus 300. And this we have plus 6 into 105. Because minus or minus is plus, right? So minus or minus will cancel each other. So 6 into 105. That's the numerator. Divide by 550. And you get 0.782 amperes. 0.782 amperes. So I2 is equal to 0.782 amperes. Okay. Next is to find the value of I3. So I3 is, here in the numerator only the third column is different. So first two columns is same. So first two column is 10, minus 3, minus 6, minus 3, 10, 0, and the third column is the voltage source column, 10 minus 5, 25, right? And as for the denominator, it's the same, 10 minus 3 minus 6 minus 3, 10, 0, minus 6, 0, 10, and this is equal to, now let's find the value here, 10 into, this is 250, and this is plus 3 into, and this is again minus 75, and this is plus 30 because minus 30. So it's minus 75 minus 30 again. So it is minus 105. Minus 105. And then we have plus 10 into, and we have this is 0, minus 60 becomes plus 60, divide by 550, right? So we have this. So here, let's do the calculation. This is 2500, numerator, right, is 2500, and this is minus 3 into 105 plus 600, divide by 550, which is 5.064 amperes. 5.064 amperes. Okay, this is the value of I3, right? So I found the value of I1, okay, I2 and I3. So now the question is, find the voltage across the 5 ohm resistor. So the current across the 5 ohm resistor is I2, right? So that means I2 into 5 ohm is the voltage across the 5 ohm resistor. That means, let's write it, voltage across the 5 ohm resistor is equal to I into R, right? Ohm's law. I into R, which is equal to I2 into 5, right? Which is equal to, and I2 is 0.782. 0.782 into 5, which is equal to, let's see, 0.782 into 5 is 3.91. So this is equal to 3.91 volt. Okay.